All right, y'all. Today we're going to talk about Extrema. So go ahead and write at the top of your notes, 5.2 notes, Extrema. And then you can write EVT, that stands for Extreme Value Theorem, Extrema, and critical points. So those are the three topics we're going to hit today. We are going to figure out how to use calculus to find max and mins instead of just by looking at a graph, because on the AP exam you got to use calculus to find extrema or maxes and mins. Okay. So, that's our graph from the do now. Let's go ahead and scroll down and make sure that these definitions are in your notes. So take 2 minutes to put these definitions in your notes. Relative or local extrema, these mean the same thing. If you see the word relative or the word local extrema, those mean the same thing on an AP question. Absolute is the same as global extrema. So, relative extrema, it's the y values on the graph where the function changes from increasing to decreasing or vice versa. So let's just make sure we know what increasing to decreasing means. Increasing to decreasing looks like this. Increasing to decreasing, that would be a max, right? Decreasing to increasing would be a min. So relative extrema basically are any time we have a max or min. Absolute and global extrema are the highest or the lowest y values, the absolute max, the highest max on the graph of a function, or the lowest min on the graph of a function. And then I want you to add 2 notes. For relative extrema, don't include endpoints. For relative extrema, don't include endpoints. For absolute extrema, you want to include endpoints. We are going to look at the ends if we're asked to find the absolute extrema. So that's super important. Absolute or global, you want to include endpoints. Relative or local, you do not want to include endpoints. Okay, let's go ahead and now use this information to solve some problems. In your notes, there's some more information about relative extrema that can be read if you're interested. You don't need to worry too much about it. We kind of covered it. Okay, so here's our first example. And you don't need to draw this example in your notes, so don't worry about that. We're just going to go over it really quick. All right, consider the graph of y equals g of x, that's this graph right here, shown at the right. State the relative extrema of g of x. Okay, so we need to look for the relative extrema. We talked about how we don't want the endpoints. We're not going to worry about ends. So let me go ahead. For relative extrema, we're not looking at the ends. We're not worried about these ends. We only want to know where the function changes from increasing to decreasing or decreasing to increasing. So let's look at those spots. Here we go decreasing to increasing. So this would be a relative extrema. Here we go increasing to decreasing. So this would be a relative extrema. And here we go decreasing to increasing again right here. So that would be a relative extrema. Okay, so let's write all those down. And let's actually write them down in the proper way. So this is important for you to know. If we're stating the relative extrema for the AP exam, you need to write it like this. Relative max is, and then the maximum or the minimum, you might want to write a note to yourself. Max or mins are y values. So make that note to yourself in your notes. Max and mins are y values. So for down here, back down here, the relative max is going to be a y value, a maximum y value at the relative max. So let's go ahead and write this is a max. And here is the relative max. That's the y value, 2. Relative max is 2. And then we're going to say where it occurs at x equals 2, right? This is the point 2, 2. So at x equals 2. Now let's do the same for the 2 relative mins that we have. Relative min is, what would you put for this? Go ahead and continue the statement. something at x equals what? All right. You could have said one of two answers. Relative min is negative 8 at x equals 3. So I'm looking at the y value at x equals, negative 3. Or you could have said relative min is 0 at x equals 4. Okay, so we have all of our relative max and mins. We've got 3 of them. Now we need to check for the absolute extrema, absolute max and min. So this is asking for our absolute extrema. Remember, extrema just means max min. So that means we need to look at the highest point and the lowest point on the graph. Okay, so let's go ahead and do lowest first. I like to start low to high, low to high. So what's our lowest point? Right there. That's our lowest point on the graph. So that's our absolute min. Let's write down. Absolute min is, go ahead and finish the statement using the same language that we used above. All right. Absolute min is negative 8 at x equals negative 3. Sweet. What about the absolute max? Absolute max. Now, you need to make sure that you pay attention to your graph and pay attention to the endpoints. For absolute, remember to include looking at the endpoints. We need to look on the ends. Look, these ends go up forever. Forever. They go up. So, our absolute max is heading towards infinity, but infinity is not a real number. So what we're going to say is absolute max does not exist because g of x approaches infinity. As you could say, as x approaches positive or negative infinity. All right, g of x is unbounded, so we don't actually have a high point. We can't reach infinity, so we don't have a high point. All right, y'all, so that's absolute versus relative max and min graphically. Now, we need to write down this theorem. It's important for you to know. So go ahead and write down the extreme value theorem. If f is continuous, you should be writing this down in your notes. If f is continuous on a closed interval, a, b, then f has a max and a min on that interval, a, b. Okay, so y'all, all this is saying is if you have a continuous function, then that function has to have a max and a min on the interval that you're looking at. Cool. And then you also need to write down this definition. Definition of a critical number or value. Definition of a critical number or value. Let me read that one for y'all. A critical number of a function f is an x value, x equals c, in the domain of f such that, okay, this has to be true. So critical number, it's an x value such that either the derivative at that x value is 0 or the derivative at that x value does not exist. If x equals c is a critical value, then c comma f of c is the critical point. So a critical point happens where this is true. Either f prime of c equals 0 or f prime of c does not exist. So I want you to make sure you have those two options. Critical point, f prime of c equals 0 or f prime of c does not exist. Okay. And y'all, you need to know this. Last thing. Write it down. Relative or local extrema. Remember, this is extrema means maxes and mins. Max mins can only occur at a critical value. So, Oh, and then, sorry, and then absolute relative max mins can only occur at a critical value. Absolute max mins, extrema, can occur at a critical number or a critical value or at an endpoint. Because remember, for the absolute, we got to check our endpoints. So, this is telling us that if we're asked in calculus to find the max or the min, then we need to check for these things. If we're asked to find the max min, check here. Check for these possible outcomes. F prime of c equals 0, the derivative equals 0, or the derivative doesn't exist. Okay, so let's go ahead and go down here and do an example. This is our last example before we practice. And write it down, please. Finding the absolute extrema of a function, of an equation. Find the absolute extrema of the function on the given interval provided the extreme value theorem, that's saying there's definitely going to be a max min if the function is continuous. If it's not, if the extreme value theorem doesn't apply, we'll explain why. Okay, so let's look at our function here. F of x equals 8x cubed minus 3x squared minus 9x plus 2. Is this function continuous? Is this function continuous? Does the extreme value theorem apply? That's what we're asking. If it's continuous, the extreme value theorem applies. All right, this function is continuous. It's a cubic. Y'all, cubics are continuous. They look like this. They go on forever. There's no holes or anything. So yes, the extreme value theorem applies. So that means we definitely have a max min. We have maxes and mins. Or mins. Or no, you do. You have both a max and a min, according to the EVT. So here's how we're going to figure out where the max min occurs. We're not going to look at a graph. We're going to use calculus. We know f of x has a max at a critical point. F of x has a max at critical points. So f prime of x has to equal 0 or f prime of x does not exist. Sorry, and f of x has a max or a min. So f of x has a max min at critical points. That means f prime of x has to equal 0 or f prime of x does not exist. Think about it this way, y'all. If f of x looks like this is a max. The derivative at that max, let me do it in a different color. The derivative at that max equals 0. The slope, f prime of x equals 0. And f of x goes from increasing to decreasing at a max. For a minimum, f of x goes from decreasing to increasing. And again, the derivative, f prime, equals 0, right? So what are we going to do to solve this? We are going to use this fact, f prime of x equals 0. We're going to take the derivative. So first find f prime of x. F prime of x equals, let's do that really quick. And we're using the power rule. So if you're struggling on derivatives, we're just using the rule. The exponent comes out in front, multiplies, and then you subtract 1 from the exponent. So we get f prime of x equals 24x squared minus 6x minus 9. Cool. We want the derivative to equal 0. So let's set it equal to 0. 0 equals 24x squared minus 6x minus 9. How do we solve this? We factor. So 0 equals, and then we can factor out, actually we can factor out, it factors into two factors, 4x minus 3, 2x plus 1. Because we have, yeah, okay, perfect. So now that we've got those factors, let's go ahead and solve. So what are my x's where f prime equals 0? X equals 3/4, and -1/2. So that's where f prime equals 0. These are the x values where f prime of x equals 0. These are critical points. Critical values, sorry. The point is the point, like at those x values. Okay, so now what we're going to do is we're going to do a candidate test for our max min. We're trying to figure out where f of x has a max or a min. So now let's go back to like f of x. We're not doing a sign test. We're actually like finding the value. So we're going to make like a little mini table for f of x. So we have f or x and then f of x, the y value. Remember f of x is the y value. And we're going to use 4 things. We are going to use our actual interval. So y'all, we're looking at this interval. Hold on, let me highlight that. -1 to 2. So that's going to go in here. -1, 2. Because y'all, we're looking for an absolute max. So we need to include endpoints. Include endpoints. So that's why I'm including those endpoints. These guys. And then we also are going to look at where f prime equals 0, the critical value. So we're going to look at -1/2. That's what we found down here, -1/2 and 3/4. Okay, now we're going to actually find the value. We're plugging these in, and I've plugged them in my calculator to find the f of x value down here. So do your calculator. This is a Calc-OK question. We plug it in into f, into this function, plug in. And we get 0 when we plug in -1. We get 4.75 when we plug in -1/2. We get -3.063. And then we get 36 when we plug in 2. Okay, so that's what we get when we plug in those x values on f of x. Remember, we're plugging into f of x. Okay, now let's answer the question. Let's answer this question. We are trying to find the absolute extrema. That means absolute max and min. Well, the only possible places are the endpoints or the critical points. That's what that theorem was saying before. So we just need to look at the lowest and the highest values in our y's here. Which one's the lowest? -3. So we're going to say the absolute min is -3.063 at x equals 3/4. And then absolute max is, what's the highest point down here? 36. Right here. At x equals 2. All right, and then we're done. So when we're finding critical points or absolute extrema, absolute max or mins, we need to find where the derivative equals 0. Those are our critical points. We need to then do a candidates test. Sorry, y'all. This is called a candidates test. That's testing all the possible candidates. These x values are all the possible candidates for maxes and mins. And then we find the absolute max and min by finding the lowest y value and the highest y value. All right, sweet. Let's do some practice.